Hello students, welcome to Legacy IAS Academy. In today's video, we are going to discuss about the supercontinents that used to exist on the earth and might exist from next 50 to 200 million years from now. So we will try to understand about each of the supercontinents that have developed on the earth's surface, how they have came together, how they have disintegrated, and what will happen as far as the surface of the earth is concerned. So first of all, to give you the idea about the supercontinent, the concept of supercontinent first time was mooted in the geography was Alfred Wegener, a German geologist somewhere in the year 1912. And it was during this time the scientists and geologists, geographers started to wonder that what happens when the world's drifting continents clump together in one big lump surrounded by a single world ocean. So basically, when Wegener started to work on his theory, which is today popularly known as continental drift theory, he combined a body of new as well as the old evidences to show that Earth's continents at once upon a time had been united together into a single landmass, which he used to call it before Eurocontinent, but later on he changed its name to Pangea. Pan plus Gia, where Pan refers to the entire or all, where Gia refers to the earth from the geo. So Pangea means all the earth. So if we talk about that, what are the supercontinents? So basically, as you know, as humans, we inhabit the land part of the earth, but the continents on which we are residing today, basically they are not the entire earth's crust that used to be millions and millions of years ago from now. Today's continent basically can be considered as nothing but a patchwork or pieces of the older large size continents, and these pieces are what we refer in geography as cratons. So supercontinent, like any ordinary continents, are also not something that exist on the earth for a very long period of time. They're also temporary, like the shape and size of a continent as far as the geologists are concerned. So how can we define supercontinent and how can we characterize the differences between continent and supercontinent? So supercontinent, the common working definition that has been accepted in the field of geography, is that any large land mass on the earth's surface which consist of more than or almost about 75% of the existing continental crust, then that can be characterized as supercontinent. Now this is very important point, because many times people have this confusion that only if the entire all the land masses will join together, then only you can say that supercontinent is formed. But this is not the case. Even as of now, 75% of the earth's continent, if they join together from a single landmass, then we can have a development or formation of a new supercontinent. Also, it is possible that maybe one part of supercontinent is breaking while another part of supercontinent is still in the stage of formation. Now, how this process has happened exactly in the past, how it will happen in the near future, we simply cannot tell with the information that is available to us. And maybe as humans, we will not be able to tell ever that how all these processes occurred in the past and will happen in the future. So we have discussed about a term that is cratons. So if you look at the today's subcontinents, continents today are also part of the earlier cratons. For example, if you look at the Eurasian continent, especially the Asian part of Eurasia, and look at large landmass of Russia, here we can see the evidences of Siberian cratons. Similarly, if you look at the landmass of North America, here we have the evidences of Laurasian cratons. If you talk about in South America, we have Amazonia craton, Rio de la Plata craton. In Africa, you have very important Cap Wall craton. So everywhere we can see that we have the evidences of the earlier craton. Like for example, in Scandinavian Europe, you have a large part of proto-continent that is called as Baltica. That is also example of the craton. So these 5-6 were the major cratons that existed almost 2.5 billion years ago on the earth. And these rocks that we see today, the rocks that are part of cratons today, are considered to be one of the oldest existing rock, oldest as well as the most stable part of the earth's crust. And one such rock structure, one such area you will find in India also, which is called as Dharwar craton. So in the past history of Earth, as you know, that Earth formed or developed somewhere about 4,500 million years ago from now. So the first supercontinent that existed on the surface of Earth is named today as Kinnorland. Kinnorland is believed to be made up of three major cratons: Valbara cratons, Superia craton, and Sclavia craton. The time period during which Kinnorland existed on the Earth's surface is believed by geologists to be somewhere in the range of 2,500 million years ago. during the Archean, or what we can refer as early Proterozoic eons. Now, the name Kenorland is given because it is associated with the Kenoran orogeny. Orogeny in geography refers to the process of building up a mountain or process of the formation of the mountain. So, the Kenoran orogeny or the mountain building event that we have witnessed in the northern part of Canada, or also we can say the border region of US and Canada today, is what called as Kenoran orogeny, and thus the landmass is called as Kenorland. If you look at the map here, 2500 million years ago, how Earth used to look like? So the answer will be it used to look like something like this. We have this large area of landmass that you are seeing. This is nothing but the Kenorland that we have discussed. And as we can see, the major features of Kenorland, you have Superior. Today you have 5 Great Lakes at the border of US and Canada, and Lake Superior is one of the lakes that used to be in the northern part of the Kenorland. Apart from that, we have Karelia, Kola region that is today part of Russia. We have Kola Peninsula that is part of Arctic region. Zimbabwe, Kapwal that was part of Africa. Dharwa region, as we had discussed, one of the cratons that has made the Indian plate. Ilgarn, Bund, Pilbara. So these were the major landmasses. These were the geographical features that collectively were joined together to form a supercontinent that we have called as Kenorland. Further, somewhere between 2100 million years to 1400 million years, another continent form, a supercontinent form, that is referred as Columbia. And if you actually look at the evidence of Columbia, or the core which used to make the Columbian supercontinent at that time, it is still found to be intact by the name of Canadian Shield today in the Laurentian region of Canada. Laurentia is considered to be one of the oldest block of the landmass that we see or we can find on the earth today. So this is nothing but a core of Columbian supercontinent. The name why the supercontinent is called as Columbia, because similarly we have the region in North America which is called as Columbia, and it was believed that this Columbian supercontinent was made up of largely a Columbia region of North America, but at the same time, at that point in time, it was also connected to the eastern part of India, and that is why it made a huge supercontinent. And thus, if you take a look at the size and the shape of the supercontinent, we can see that we have a Laurentia in the north, we can see Africa in the northeastern direction, we have China here, and this is our India here, then Africa, Amazonia, Baltica, Siberia, Greenland. These were the major cratons that had came together, joined together to form this supercontinent that we call as Columbia. Further, as time passed, Columbia disintegrated, and again all the land masses joined together to form next continent, which is called as Rodinia, which is believed to have existed somewhere between 1000 to 600 million years ago. And it is also believed by geologists, and we also have ample evidences to prove this point, that all of the continents that we see across the world today had, and their land masses had basically derived from the Rhodinian landmass. And also Rodinia was the first supercontinent where we have the evidence of development of first complex animal, the evolution of the complex animal on the earth's surface, especially around the coastal shallow seas that were surrounding the Rhodinian supercontinent. Rodinia and the existence of Rodinia is well established among the community of specialists, and we have much more detailed information about Rodinia as compared to the other 3 supercontinents that we have discussed before. If we take a look at the Rodinia, shape of Rodinia, how it used to look like. So first of all, it was the Mark and Diana McMenamin, the two people who have named the supercontinent. And as we can see, apart from a small part of Africa and South America, a large part of Antarctica, India, China, Siberian landmass, Laurentian Shield, Amazonia, Rio Plateau, West Africa, Baltica, all these were collectively joined together. These cratons, as we have called it before, were joined together to form this big landmass that is called as that is what we have called as a Rodinia. Rodinia, basically, if you look at the name, the Rodinia word has a Russian origin, where basically it was named by Mark and Diana McMenamin, and also the sea, a large sea, the vast ocean that used to surround this Rhodinian landmass was given the name of Mirovia, which is also a word of Russian origin. So at that time we have one supercontinent, Rodinia, and one large super ocean, that was Mirovia. Then further after that, somewhere again Rodinia separated apart, and then all the land masses were separated apart. Again they fused together to form the last supercontinent, that is called as Pangaea. Pangaea used to be supercontinent that existed somewhere about 300 million years ago, in what we can call as late Carboniferous time. And the first evidences to support the theory of Pangea was given obviously by none other than the Alfred Wegener, who gave a lot of evidences also and a lot of postulates also to support his theory of continental drift. And it is believed that Pangea was a complete supercontinent. All the land masses that we see on the earth today, all the continent that we see on the earth today, the 7 continents which we have today, and the 5 oceans that we see across, all basically were merged together to form a single supercontinent, a single super ocean, and they used to encompass almost up to 90% of the entire continental crust of the earth. However, due to various forces, somewhere around 200 million years ago from now, what we refer today as Triassic time period, Pangea started to break apart. And first of all, it separated apart into 2 different continental landmasses, one in the north, which is called as Laurasia, and one in the south, which is called as Gondwana land. And it was the Gondwana land of which Indian plate was also the part of. So if you look at the picture here, we can clearly see this is the structure of Pangea, where we can see the all the land masses, all the continents have been joined together, stretching all the way from Arctic Ocean, North Pole in the north, to Antarctica, or we can say in the southern hemisphere in Antarctica, up to Antarctica. So as we can see, the entire landmass was joined together, which is called as Pangea, and it was surrounded by a large water body, large ocean mass, which was named as Panthalassa. And then between the Laurasian and Gondwana landmass, as the Pangea separated apart, you have opening of a small sea that we call as Tethys Sea. And today, the Mediterranean Sea that we see today between Africa and Eurasian continental landmass is nothing but a remnant of the Tethys Sea. Now, this was the latest supercontinent that has developed, and from that supercontinent, now we have several different continents, 7 different continents that have come apart, on which on one of which we are living today. So the question comes that what will happen in the future if suppose we go 10, 20, 30 million years in the future, what and how the configuration of the world's surface or world's landmass will change. So answer lies in the fact that if you look at how the continents are moving today, we can clearly see, if you take example of North American continent today, it is continuously moving toward Asia. And if nothing changes dramatically, it is believed that 2 continents, that is North America and Asia, will join together to form the 5th supercontinent after Pangea. And obviously, since largely it is forming due to joining of America and Asian continent, it will be called as the Amasia supercontinent. Similarly, not only these 2 continents, also we look at the Africa. So Africa already is continuously moving toward the north and is going to meet to Europe, and thus it will close the last remnant of the sea that we have just discussed, that is the Mediterranean Sea. Similarly, not only this, Australia is continuously moving northward toward Asia. Antarctica is expected to follow suit and start to follow toward the northward Asia, and thus the Atlantic Ocean will gradually start to become more bigger. It will keep on expanding, and finally you have the America, North South America will join together with Asia, and then Africa will join with the Asia, Antarctica, Australia will join with the Asia, and thus the Atlantic Ocean that we see today will become a very large super ocean that will that would basically expand into what we can say as similar to Panthalassa. So we'll have Amasia, that is a large continental landmass surrounded by a single water body. So this is how, if we go 280 millions from now, the Earth's shape should look like if nothing drastic or if no drastic changes happen in the movement of the plates as of now. So we can see we have Africa, Arabia, India, Eurasia, we have Australia, Antarctica, America, all joined together to form a single landmass that we can call as Amasia, surrounded by a large super ocean, which may be renamed something. As of now, it has not been named anything. So I hope you understood about how the Earth's surface is not static, is not steady. It keeps on changing its configuration, its shape, its position. And I hope you understood about the concept behind the supercontinent. If you like the video, please hit the like button, share it with fellow aspirants, as well as subscribe to our channel for more such content. Thank you very much.